Rounding off and rules for arithmetic operations. Rounding off is a method that is used to report the result of a computation which has more significant figures than required. Let us look at rules for rounding off. The digit preceding the insignificant digit is left unchanged if the insignificant digit to be dropped is less than 5 or increased if the insignificant digit is greater than 5. Suppose we need to round off 5.35864 to just 3 significant figures. Last insignificant digit, 4, is less than 5. So, when 4 is dropped, the digit preceding it, that is 6, is left unchanged. 6 becomes the next insignificant digit, which is greater than 5. So, when 6 is dropped, 8 is increased by 1. 9 is greater than 5. So, when 9 is dropped, 5 is increased to 6. Thus, 5.35864, after rounding off to 3 significant figures, becomes 5.36. Ambiguity arises when insignificant digit to be dropped is 5. To resolve this, we follow one more rule. When an insignificant digit is 5, the preceding digit is left unchanged, even if it is even, and is increased by 1 if it is odd. For example, the exact value of speed of light is 2.99792458 into 10 power 8 meters per second. Suppose we would like to round this off to one significant digit. When 8 is dropped, 5 is increased to 6. When 6 is dropped, 4 is increased to 5. When 5 is dropped, as 2 is even, it is left unchanged. When 2 is dropped, 9 is left unchanged. Continuing this way, we get the value of speed of light as 3 into 10 to the power 8 meters per second. Rules for arithmetic operations with significant figure. The result of arithmetic operation of a measured value must reflect the uncertainties in the original measured values. The reported result cannot be more accurate than the measured values. Hence, the final result should not have greater number of significant figures than the original numbers from which it was obtained. In multiplication or division, the final result should retain as many significant figures as there are in the original number, with the least significant figures. For instance, maximum amount of water that can be stored in a swimming pool can be found out by calculating its total volume, which equals to the product of its length, breadth, and depth. Its measured length is 7.324 meters. Measured breadth is 3.664 meters and measured depth is 1.63 meters. The volume comes out to be 43.741 cubic meters up to 3 decimal places. It would be absurd to report the calculated value of volume to a precision of such high order, when clearly the measurements of the parameters on which it depends have far less precision. The length and breadth have 4 significant figures, while the depth has just 3. Hence, as per the rule, volume must have 3 significant figures, which are the least of 3. Thus, the volume of the pool after rounding off should be reported as 43.7 cubic meters. The rule for addition or subtraction is different from that of multiplication or division. In addition or subtraction, the final result should retain as many decimal places as there are in the number with the least decimal places. For example, 3 different rods of length 6.32 meters, 3.6 meters and 4.66 meters are joined to form a long structure. The total length of the structure must be reported as the sum of 3 lengths up to 1 decimal place, which is the least number of decimal places among the measured values. So, length of the structure is reported as 14.6 meters after rounding off.